Alright guys, we want to use middle sums of 6 rectangles to estimate the area bounded by these functions, these given functions. And we want to do it on this interval here, and this is an important part that you recognize. If we want to do it on this interval, that's going to be the total width that we're checking out. So the total width, the distance from -3 to 3, is going to be 6. And if you look up here, we're going to use 6 rectangles. So that's going to help you identify the width of one rectangle. Total width is 6. This is generally how you do it. You're going to use 6 rectangles. So that means the width of each rectangle is 1. Alright, we talked about in class how you can actually do these without a graph, because all we need is the width, and then we plug in the midpoint. Because we're using middle sums, we plug in the midpoint into the function that we're interested in, and that'll give us the height of each rectangle, and that allows us to calculate area essentially just through algebra. If you want to get a picture of what this thing looks like, you can use your graphing calculator. So let me pop this up here. We would go to y equals, and we would enter this function into y equals, and that'll give you an idea when you graph it of what this thing looks like. So we're going to plug in this function right here, x cubed minus 4x. And hit graph, and here's the graph of that thing. So let me just copy this onto our page here, and that'll give us an idea of what we're looking at. Oops. So this is the graph that we're looking at. We're looking at it from x equals -3, so we go over 1, 2, 3. So let me just draw on here. We're looking at this thing basically from here, and then we're going to go up 3, 1, 2, 3, over to here. So all of this area, this chunk right here, this chunk right here, this chunk right here, and this little piece right there, that's the area that we're trying to estimate. A couple other things of note here. We need to go find the roots of this particular thing, which means we set it equal to 0. So 0 equals, and what we can do is we can just factor this. We can take out a greatest common factor. So x is the greatest common factor between those two. And what we're left with on the inside is x squared minus 4. So we split that up using that 0 product property. So we'd get x equals 0 or x squared minus 4 equals 0. And this is going to factor to x plus 2, x minus 2. So you don't actually technically have to do this, but it should give you an idea of where the roots of this thing are. There's a root at 0, which would be this piece right here, or this root right there in the graph. There's one at -2, and there's one at +2. There's your -2, there's your +2. So like we talked about before, this stuff's actually not really even required. It does give you a good idea of what's going on to get a visual of it. But this stuff right here, you don't technically have to do. Just allows you to see where the roots are and really what area you're dealing with. Alright, so let's go through the process. We'd already figured out that the width of each rectangle is equal to 1. So let's start off with rectangle 1. Rectangle 1 would be this piece over here. So we're going to draw a rectangle that goes down until it hits at that midpoint. And this is going to be an overestimate for this particular piece because we've got this section right here that looks like it's maybe a little bit greater than the section that we've omitted. But again, that doesn't really matter. If we call this rectangle 1, we need the midpoint of that rectangle, and we need to plug that midpoint into this function. So the midpoint of this rectangle is going to be -1, 2.5, or -5/2. So we're just going to plug that in. So we would get y equals -5/2 cubed minus 4 times -5/2. So we simplify this, and we're going to get -125/8 plus negative times a negative is a positive. 4 times 2 is 8 plus 5 is going to be 13/2. Get a common denominator. Common denominator of 8. So we're actually going to add times 4 is going to give us 52/8. So combine these two, and it looks like you've got, let me see, 73/8. That's a negative technically, but again, we're talking about the height of this thing, and so we'll throw the negative in, but at the end, we don't care about the negative. We just want to know what the height of that particular thing is, so we'll take the absolute value. So we're going to go through this process for each one of these rectangles. So I'll kind of do that quickly. Next rectangle is actually going to be this guy right here. We're going to go up till it hits at the midpoint and over. So the midpoint of rectangle 2, I'm going to call that rectangle 2. We're going to go over 1.5. So 3/2. It's -3/2. That's what we're going to use to plug in to this function here. So we got y equals -3/2 cubed minus 4 times -3/2. This ends up being -9/8. Oh, sorry, -27/8. Plus, that's going to be 12/2 or 6. But again, we need a common denominator. So we'll get -27/8 plus this times 4, this times 4, that's 48/8. So our height on this guy is going to be, what is that, 19/8. And that's a positive. So we got 19/8 here. Looks like it's a little over 2. Third rectangle. It's actually, because this thing is symmetric, it's going to look pretty similar. So hopefully we'll come up with something similar there. Midpoint of that is going to be -1/2. Plug it in to that function. There's x cubed minus 4 times x. That's going to be -1/8 plus 4 times 2 is 8 plus another 1. It's going to be 9/8. Sorry, not 9/8. That is, let's see, 4/2. Common denominator. Multiply this by 4 and we get -1/8 plus 16/8, which leaves us with 15/8 as the height. Now we talked about that property of symmetry, and this function is going to be symmetric If you didn't do the graph, then you can go ahead and calculate the rest of them. R4, the only difference is these are going to be negative for R4 and R5, and then R6 would be positive and equal to that value right there. So bringing that all together, our area estimate using Riemann sums, 6 triangles, is going to be 2. We're going to have 2 of this rectangle plus 2 of this rectangle. And again, we're using absolute values because we're interested in the area. We're not interested in whether it goes up or down. Simplify. That's going to be 146 over 8 plus 38 over 8 plus 30 over 8. Plug that in, that looks like it's 68. It's going to get us to 214, I believe. And there's your area estimate. So 214 divided by 8 is about 26.75, or it is 26.75. So that would be our area estimate using 6 rectangles for this particular function.